Greetings, Detective. Today I want to talk about something small, something you can't even see, but something that quietly destroys more steam boilers than bad piping, bad water, or bad installers ever will. What is it? That pesky O2 molecule. And the crazy part, even after we boil oxygen out of the water, it still worms its way back in. My name is Ray Wohlfarth, the Boiler Room Detective. My comprehensive series, 14 boiler books, covers everything from installation and troubleshooting to advanced system design. These are available now at Pronto Heating Supplies, TF Campbell, heatinghelp.com, and Amazon. Okay, let's start with the basics. Oxygen and steel do not get along. Put them together with heat and water, and you get oxidation or rust. Inside a steam boiler, oxygen causes pitting in the boiler sections, thinning of the condensate return piping, and eventually boiler failure. Here's a couple ominous thoughts. Dissolved oxygen is 10 times more corrosive than carbon dioxide. Oxygen corrosion is twice as corrosive at 86 degrees than it is at 122 degrees Fahrenheit. But steam drives oxygen out, right? I could hear you asking. Here's where a lot of people get tripped up. When water boils, oxygen is driven out of the water. That's true. In fact, steam systems are better than hydronic systems in that regard. But here's the key point. A steam system doesn't stay full of steam. It breathes. When a boiler shuts off and the steam collapses back into water, what takes its place? Air. And air is about 21% oxygen. Every time that boiler cools down, air is pulled in through the vents, through leaks, through vacuum breakers, worn gaskets are packed. Now that oxygen is sitting on top of the water. When the boiler cools, the oxygen is reabsorbed into the water to the tune of 8.6 parts per million when the water is at 70 degrees Fahrenheit. Oxygen loves cold water. So where does it do the most damage? The condensate returns, especially wet returns, buried returns, or condensate tanks and receiver systems. That returning of water has absorbed oxygen on its way back to the boiler. Then we heat it back up and oxygen attacks the metal all over again. The worst offender, idle boilers. Here's where I see the most damage. Boilers that sit idle over the summer between steaming cycles, seasonal buildings. Cold water holds more oxygen than hot water. So an idle boiler full of water is basically a slow motion corrosion experiment. On large industrial boilers, they use a deaerator to keep oxygen at bay. Industry icon Dan Holohan talks about a poor man's oxygen removal system he saw on a job site. On the makeup water pipe to the system, the contractor installed a water heater and set it for the highest temperature. Just downstream, he installed a micro bubble air removal fitting. They weren't able to remove all the oxygen, but they were able to remove most of it. Here's the main culprit in no deaerator systems. Cold water makeup. Every gallon added brings fresh 8 to 10 parts per million oxygen. High makeup equals high oxygen load. Vented atmospheric tanks. The open vent lets air, 21% oxygen, diffuse right in. Hot condensate splashing around. Even worse, it aerates like crazy. Condensate system air leaks. Leaky traps, bad seals on pumps, vacuum breakers pulling air, or open receivers all let oxygen sneak in before it even hits the tank. Shutdown and idle periods. Boiler cools, vacuum forms, air gets sucked in. Offline boilers without proper layup are pitting magnets. No mechanical removal. Without a deaerator, You're 100% reliant on chemistry to handle it all. So, how do we fight that pesky O2 molecule? We can't eliminate oxygen completely, but we can limit the damage. Here's how: keep the system tight, fix leaks, minimize freshwater makeup, insulate condensate return pipes, consider chemical treatment, and keep boilers hot when possible. Remember, fresh water is the enemy of steam systems. So the next time someone asks why a boiler rotted out earlier or why the returns disappeared, remember this: it wasn't magic, it wasn't bad luck. It was that pesky O2 molecule finding its way back in, one shutdown at a time. If you've seen oxygen damage in the field, drop it in the comments. And if you want more deep dive boiler explanations, hit subscribe. This is Ray, the Boiler Room Detective, and I'll see you on the next case.